How would you survive if you were forced to enter a black hole? Well, to be honest, no matter what kind of black hole you chose, the prognosis isn't good. Your body would go through a process known as spaghettification. If you bravely dove into a stellar mass black hole, you would be stretched and compressed equally throughout by the black hole's gravitational pull. A black hole is a region in space that is invisible and where the gravity is so strong that even light cannot escape. When a star is dying, dense stuff is compressed into a very small area, creating a black hole, which explains why its gravity is so intense. Imagine if a black hole could be produced in a laboratory. Yes, you heard it right. To test a Stephen Hawking idea that has been around for a while, scientists have now built a black hole in a lab. A group of physicists from the University of Amsterdam utilized a chain of atoms arranged in a single file to better understand the behavior of a black hole and produced the black hole event horizon. The new analog might aid improve our understanding of the enigmatic radiation assumed to be released by actual black holes in outer space. Its formation succeeded in demonstrating Stephen Hawking's hypothesis from 1974, according to which the black hole released a peculiar type of radiation known as Hawking radiation. Hawking radiation results from perturbations in the quantum fluctuations brought on by the spacetime rift created by the black hole. Black holes are by far the most fascinating celestial bodies. Though they did manage to obtain black hole images, they are all blurry and lacking in fine detail. That's because it's challenging to notice these void-like objects since the light of space physically bends around them. But with this brand new artificial black hole, researchers might be able to take a closer look. According to the researchers, it could be able to ease some conflict between the two working frameworks. The general theory of relativity and quantum mechanics are the two current theories that seek to explain the inner workings of our universe. Every cause in general relativity has a distinct, local consequence since events are continuous and predictable. In contrast, events brought about by the collision of subatomic particles in quantum physics occur in leaps and have probabilistic, rather than definitive results. However, the theory of Hawking radiation and this novel simulation of black holes may potentially aid in harmonizing the two frameworks. If we can do that, it could help us get a better comprehension of how the universe functions. That alone may reveal more information on how black holes function, possibly even enabling researchers to distinguish between wormholes and black holes. The temperature increase caused by this artificial black hole is consistent with what is predicted by theory for a black hole system. Even in the lab where the researchers produced it, the artificial event horizon had luminous characteristics. The fact that the radiation glows indicates a peculiar space anomaly because a black hole's event horizon is intended to be a region from which neither light nor matter can escape. In science class, we all hear about the power of a black hole and how we would all ultimately fall into one. Even an attempt to travel faster than light would not make this inevitable because of the density of matter in the center, which makes this conceivable. Since information is not currently relayed back to the universe, we have no means of knowing what happens to an item once it passes a black hole's border. Stephen Hawking said in 1974 that these breaks in quantum fluctuations would produce a specific kind of radiation that might contain some information. However, only when a portion of the chain stretched beyond the event horizon did the artificial black hole event result in a temperature increase that was consistent with theoretical predictions for an analogous black hole system. It is speculated that Hawking radiation may be greatly influenced by the entanglement of particles that cross the event horizon. According to simulations that started by recreating spacetime that was conceived of as flat, the radiation was only thermal for a specific range of Hopf amplitudes, the researchers report. Therefore, there may be certain circumstances in which Hawking radiation can emit thermally. These circumstances may only occur when gravity modifies the spacetime warp. This may provide a platform for investigating basic quantum mechanical ideas with gravity and curled spacetimes in diverse condensed matter contexts. The new study was published just after scientists found a black hole that is 1,560 light-years from Earth, making it the nearest black hole ever found. Now let us wait for future discoveries that could expand our thoughts. Thanks for watching. If you liked this video, make sure to subscribe for more content like this and click the bell button to receive notifications of new videos.